Our undergraduate students are, some of the best students in the country. We have an undergraduate program which is very selective. So when students arrive on campus, they are very driven, they're very motivated, and this becomes immediately apparent in the courses that we teach.
The first 2 years of study that the students go through is predominantly in the college, and so they're taking courses in humanities, in economics, in writing, gaining a very, very broad understanding and perspective of the world. The core program that the students do in their first 2 years lends a particular breadth to their overall program. After those 2 years, they come into the engineering school and they focus then intensely for these 2 years on thermodynamics, heat transfer, mechanics of solids, mechanics of fluids, control systems, design.
It is very difficult these days to imagine that one person alone would design a car or a plane. So you must learn how to actually coordinate your efforts with those of your peers. And one of the most wonderful things that we have to offer is a sequence of courses in design.
They do a good job in some of these classes of pushing innovation, especially in the senior design course. You can really go in whatever direction you want to create something unique.
We have the largest undergraduate teaching laboratory within the engineering school. We offer the most modern equipment as well as traditional, machining capabilities, cutting metals, cutting plastics with laser tools, 3D prototyping, 3D printing, electronic systems.
The course basically involves the students getting together in a group, and they will design and build pretty much, anything. I've seen a number of different types of designs.
Our project is a haptic feedback glove. You'll be able to play a video game and pick up virtual objects and feel the virtual objects.
Students also participate in clubs. For example, the Society of Automotive Engineers participates in the Formula One race car.
We completely redesign and build the entire thing from scratch. We weld the entire chassis together. We design the frame. Everything is custom made except for the engine, essentially, which we tune ourselves. I learn a lot about, sort of the more real hardcore engineering.
I'm always open to having more and more undergrads in our laboratory. You're going to get a Columbia undergrad and they're going to be smart, and they're going to be proactive, they're going to be self-starters.
I approached Professor Myers last year to see about doing research with her in the spring, and she was very much willing to take me on. So I did the research over the summer, and I'm continuing it in the fall.
Undergraduates love to fabricate, dream up new ideas. We want to provide them with a great research experience that they can be proud of, and that would also shape their future in terms of deciding what they want to do in their careers.
One of my professors that I had for a robotics class actually recruited me for an internship over the summer at Phillips, where I was doing research with medical robots.
The jobs that a mechanical engineer that graduates from our university would be quite vast, I think. There would be opportunities in traditional ME firms. We have Boeing, which hires a lot of our ME graduates.
One opportunity that is very much due to being a student here is I was offered a job at the Boeing company. As a result, it was an on-campus recruiting event.
We're quite proud of the fact that we intend to graduate people who go on to be leaders in their respective professions.